And so we are going to continue with polar coordinates. In the last video, we went through problems 1 and 2. We're going to finish with 3 and 4 in this one. In problem 3, it asks us to find the slope of the tangent line for the curve r equals 1 plus sine theta at theta equals pi over 3. And so that is the challenge here. So we want dy dx, which is going to be dy d theta over dx d theta. And if we look back again at what I highlighted in yellow in the previous video, we could see that that's going to be dr d theta, or I'll just write that as r prime sine plus r cosine, and on the bottom it's r prime cosine minus r sine. So r prime sine plus r cosine of theta, and on the bottom r prime cosine minus r sine theta. All right, so now what's left is to find and evaluate. So r prime, this is dr d theta, and r is given as 1 plus sine theta, so that derivative is going to be cosine of theta. That is multiplied by sine of theta, plus, now r is 1 plus sine theta, which is being multiplied by cosine of theta. And filling in the bottom, again, r prime is cosine of theta, and that's multiplied by cosine of theta, so that is cosine squared, minus 1 plus sine of theta for r, times sine of theta. So while we can evaluate right here for theta, I'm just going to go through the effort of simplifying as much as we can. So I see that on top I could factor out a cosine, which will leave me with a sine plus 1 plus sine, so 1 plus 2 sine theta. On bottom, we have a cosine squared minus sine of theta minus sine squared of theta. So that's going to be cosine squared theta minus sine squared of theta minus a sine of theta. And that's what we have in the denominator. All right, so what's left is to figure out how we might want to simplify this, and we can convert the cosine squared into a 1 minus sine squared, which might be advantageous. So let's go ahead and take a look at that. If we make that change on the top, we still have cosine of theta times 1 plus 2 sine theta. On the bottom, 1 minus sine squared in for cosine squared is going to give us 1 minus 2 sine squares minus a sine of theta. And so it's at this point, and again, you could have done this earlier, where we want to evaluate at theta of pi over 3. Remember, this is radians, so adjust your calculator if it isn't appropriate. And when you make this evaluation, you should end up with -1 for the slope of the tangent line at that theta value. So this one happens to work out pretty simply. For problem 4, we want to determine the horizontal and vertical asymptotes of the polar curve r equals 1 plus sine theta. Notice that's the same polar curve that we just used in problem 3. So we'll likely find the simplification effort that I went through to be useful at this point. So let's go ahead. Horizontal asymptotes. Now this is when the slope is 0. And the slope is only going to be 0 if the numerator is 0, and the numerator is cosine of theta. I'm looking on top with problem 3 times 1 plus 2 sine of theta. And this product, as with any product, is going to be 0 only when one of these terms is 0. So cosine of theta is 0. So cosine of theta is 0 for when theta is pi over 2 or 3 pi over 2. 1 plus 2 sine of theta, so our other term is 0. So here you're going to look for theta is the arcsine of negative 1/2. And that will be at 7 pi over 6. And also at 11 pi over 6. So there's two angles for each when you're looking at the period from 0 to 2 pi, so a full cycle. If you look at a sketch, you'll see that that both these functions will be 0 twice within that interval. So that's where the horizontal asymptotes will occur. Now the vertical ones are going to be when dy dx is either plus or minus infinity or undefined. And that's only going to be when the denominator is 0. And the denominator we have as 1 minus 2 sine squared theta minus sine of theta. So that's the one that we want to figure out when is that going to end up being 0. Let's play with this a little bit and see if there's anything more that we could get from this. I'm going to factor a sine out. Let's see, and write this. So when you factor sine, you're going to get 2 sine theta plus 1. And that is multiplied by the sine theta. So there is no parenthesis around the 1 minus sine theta up front. And we still want to know when is this going to be 0. Let's think about if there's any other manipulation that we may be able to go with. And you know what? It might actually be advantageous to use the previous form of the denominator. I'm just looking if the cosine squared minus sine squared minus sine might be more helpful to use here. And it looks like it might be. So let's work from just seeing if there's anything else we could do here. Let's actually manipulate that denominator a little differently. So I'm gonna go back. I'm gonna use that cosine squared. I'm looking over here. I'm gonna make use of the cosine squared minus sine version. So we haven't done anything wrong with this, but I think it's going to be easier to manipulate a little differently. And so cosine squared theta minus sine squared of theta minus sine of theta. We want to know when is this going to be 0. I'm going to make the substitution for cosine squared to be 1 minus sine squared, which I know we did earlier, but I'm not going to combine it. I'm also going to factor a sine of theta from the right side portion of this, and that sine is going to be multiplied by sine of theta plus 1. So far, so good. And then I see that this 1 minus sine squared can actually be viewed as a 1 minus sine of theta times a 1 plus sine of theta. And that's going to be helpful because now both parts, the left and the right term on the left side, have a 1 plus sine of theta in it. So I'm going to factor that out. I'm going to pull out a 1 plus sine theta. And that is going to leave me with a 1 minus sine theta on the left and a minus sine theta from the right term, which means that our product is 1 plus sine theta times 1 minus 2 sine thetas and as before, we want to know when is this going to be 0, which will be when either of the terms, in the product are 0. And so this term here is going to be 0. We're looking for what thetas is sine of theta equal to 1, or arc sine of what is arc sine of 1. That's what or of negative 1. And that's going to be at 3 pi over 2. The second term here, we want to know theta is the arc sine of 1/2. And that will occur for theta of pi over 6 and 5 pi over 6. So those angles will give us our vertical asymptotes. That's it for this topic. Next coming up is going to be